Welcome back. Yesterday, or the last time you watched the videos, we talked about product of powers and quotient of powers. With product of powers, remember, same base, you add the exponents. Same base on a quotient or division, you subtract the exponents. Today we're going to talk about what you have if you have a power raised to a power. So let's think about this event. 3 squared raised to the 4th power. Well, we know that 3 squared to the 4th power would be 3 squared times itself 4 times. That's what this exponent of 4 tells us. Now, we know that 3 squared is equal to 3 times 3. And so what we have when we have 3 squared to the 4th power is that we have 3 times 3 times itself 4 times. Well, if you notice, 3 squared to the 4th power would have 3 multiplied by itself 8 times. What do you notice with this 2 and this 4? When we had products of powers with the same base, we added the exponents. But here we have a power raised to a power, and you'll notice that 2 times 4 is equal to 8. So the power of a power, we actually multiply the exponents. So when you have a power raised to a power, you multiply the exponents. Let's do some examples. So here we have a power of a power. So if I have 5 to the 4th to the 3rd power, we know that it's going to be 5 to the 4th times 5 to the 4th times 5 to the 4th. Right? Which we know is going to be 5. In fact, if we use the other rule of adding the exponents, we get 4 plus 4 plus 4, which is 12. But it's simple just to multiply these. So let's do that with this example. 7 squared to the 3rd power would be 7 to the 2 times 3, which is 7 to the 6th. Here, if I have 14 to the 5th raised to the 3rd power, it's just the same as saying 14 to the 5 times 3, or 14 to the 15th power, which is a very large number. We are now going to talk about a special thing called power of a product. Now, power of a product is kind of a cool thing. And this was not in your original notes, so if you want to take some time to write this down or just watch what we do. If I have 2 to the 3rd times 4 to the 3rd, notice the bases are not the same. 2 to the 3rd is the same thing as saying 2 times 2 times 2. We know 4 to the 3rd is the same thing as saying 4 times 4 times 4. Notice if I take this 2 and this 4 and we use something called the associative property, or the commutative property, means we can move things around. I'm going to commute this 4 over here and say 2 times 4. I'm going to commute this 4 over here and say 2 times 4, and then commute there. And then I'm going to use the associative property, the grouping, to show that I can group these, and group these, and what I end up having is 2 times 4 raised to the 3rd power. I happen to know 2 times 4 is 8. So when you have something that has possibly a different base, but same exponent, it turns out you can multiply the bases while you keep the exponents the same. For example, if I had 3 squared times 4 squared, I now know that I can just call that 3 times 4 raised to the 2nd power, or 12 squared. So it turns out my rule is if my bases are different and my exponents are the same, I can just multiply my bases together and keep my exponent the same. So here for this example, I have my bases are 5 and 3, so I multiply those and I keep my exponent the same. So this is just 15 squared. I happen to know that's 225, but most of the time I'm just happy with you just telling me what the exponent is. Same with here, 12 squared is the same as 144, but I'm really more interested in the exponent and your power. It turns out the same thing if you have a power of a quotient. 10 to the third power would be the same as 10 times 10 times 10. 5 to the third power is 5 times 5 times 5. I could just simplify each of these. This is the same as 2 over 1, 2 over 1, 2 over 1. So I end up getting 2 to the third power. But it's the same exact rule, where if you have the dividing a power with dividing powers that have the same exponent, you can just divide these, the numerator and the denominator, the bases, and you keep the exponent the same. So you get 2 to the third power. The rule again is if you have a to the m divided by b to the m, you have the same exponent, different bases, you just divide the bases, and then you get the exponent. You have enough information now to actually complete page 5 and 6. Tomorrow we're going to talk about 0 and negative exponents, is what you will need in order to complete pages 7 and 8.